Now, carboxylic acids are nothing but the organic compounds which contain COOH group are called as carboxylic acids. The organic compounds which contain COOH group, this we can write like this also, C double bond O OH, are called as carboxylic acids. Okay. Now, so here these carboxylic acids are classified into two types. They are aliphatic, aromatic. Aliphatic carboxylic acids and aromatic carboxylic acids. And you know, these aliphatic carboxylic acids are the long chain carboxylic acids which are obtained, the long chain carboxylic acids which are obtained in the hydrolysis of oils and lipids are called as fatty acids. Fatty acids are nothing but the long chain aliphatic carboxylic acids which are produced in the hydrolysis of oils and fats. Oils and fats are called as fatty acids. The examples of fatty acids are, the first one is palmitic acid, and stearic acid, and oleic acid and linolenic acid. These are the examples of fatty acids. They are long chain aliphatic carboxylic acids and which are obtained in the hydrolysis of oils and fats. And next, when come to this aliphatic carboxylic acids, okay, the first example of this aliphatic carboxylic acid is HCOOH. The common name of carboxylic acids, aliphatic carboxylic acids or carboxylic acids, are obtained from their source. The source of this HCOH is red ants. So that is why it is its common name is formic acid. The common name of HCOOH is formic acid because it is isolated, it is obtained from red ants. So that is why it is called as formic acid. And when come to the IUPAC names, in IUPAC, the carboxylic acids are called as what? Oic acids. This oic acid is the secondary suffix. The secondary suffix of carboxylic acids is oic acid. Okay. So therefore, the IUPAC name of HCOOH or formic acid is methanoic acid. Methanoic acid. So because it contains only one carbon, so methane oic acid, methanoic acid. Now we'll go for the next one, CH3COOH. The common name of this CH3COOH is acetic acid. Acetic acid. Okay, because it is obtained from acetum. Okay, acetum. Acetum is nothing but vinegar. You know, dilute acetic acid is called as vinegar. And the IUPAC name of this compound is, here two carbons are there, CH3COOH, two carbons are there. So the IUPAC name of this compound is ethanoic acid. Acetic acid is the common name and ethanoic acid is the IUPAC name of CH3COOH. And similarly, the next one is CH3CH2COOH. Okay, here the common name of this carboxylic acid is propionic acid. Propionic acid, and the IUPAC name is here 1, 2, 3 carbons are there. So IUPAC name is propanoic acid. Propanoic acid is the IUPAC name and propionic acid is the common name of this carboxylic acid. Now, and the next one is CH3, CH2, CH2, COOH. Okay, the common name of this compound is butyric acid. Butyric acid. Why? Because it is obtained from butter. Okay, that is why it is called as butyric acid. And the IUPAC name of this compound is here This carboxylic acid contain 1, 2, 3, 4 carbon atoms. So IUPAC name is butanoic acid. Butanoic acid. Okay. Oic acid, but 1, 2, 3, 4 carbons are there. So but, ane, carbon single bonds. So you have to remove terminal E by oic acid. So therefore its IUPAC name is butanoic acid, and it is obtained from butter. And next one is CH3, CH2, 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 1, 2, 3, 4, 5 carbons. The common name of this carboxylic acid is valeric acid, and it is obtained from roots of valeric plant. That is why it is called as what? Valeric acid. It is the common name. Okay. And when come to the IUPAC name of this compound, here it contain 1, 2, 3, 4, 5 carbons. So pentanoic acid. Pentanoic acid is the IUPAC name of this compound, and valeric acid is its common name. Now we will take some side chains in the carboxylic acids. You know that carboxylic acid COH is a chain terminating function group, and it always get a first position, first number. Now if it is like this, CH3, CH2, here it is say CH3 and it is COOH. Okay. So in this, this is the parent chain, and numbering should be given from this carbon 1, 2, 3. Okay. And the methyl side chain, methyl substituent is present at a second carbon. So 2-methyl. Here how many carbons are there? 3 carbons are there. 1, 2, 3. So propanoic acid. Propanoic acid. Propanoic acid. 2-methyl propanoic acid is the IUPAC name of this compound. But in common names, okay, you know, generally we use the alpha and beta. Okay, alpha and beta are used in the common names. So in the, okay, its common name is alpha-methyl. 3 carbons are there. So okay, the common name of the carboxylic acid which is having 3 carbons is the propionic acid. So alpha-methyl propionic acid is the common name of this carboxylic acid. Similarly, if you take Cl, COOH. Okay. Now its IUPAC name is 1, 1, 1 trichloroethanoic acid. Ethanoic acid. Why? Because it contains only 2 carbons. So 2 carbons, the root word is oic acid, ethanoic acid, and the common name is trichloroacetic acid. Okay. Now ethanoic acid 111 trichloroethanoic acid is the IUPAC name, and the trichloroacetic acid is the common name of this compound. Okay. I am taking a few more compounds. In that we will go for cyclic compounds. Here when come to the cyclic compounds, now say this, you know that it is called as cyclopropane. Now if you write COH here, then its name will be cyclopropane carboxylic acid. Cyclopropane carboxylic acid. And if it is like this, say I have written here CH3, then numbering will be 1, 2, 3. So 3-methyl cyclohexane carboxylic acid. Okay. Now its name is 3-methyl cyclohexane carboxylic acid. And if it is like this, COOH and it is OH. You know that this compound contain 2 functional group. One is carboxylic acid and the second one is alcohol function group. Among alcohol and carboxylic acid function group, you know that whenever a organic compound contain more than one functional group, among those functional groups, one functional group should be selected as a principal functional group. So, among alcohol and carboxylic acid, the principal functional group is a COOH. Okay, when it is considered as when it is not considered as a principal functional group, then it should be considered as a side chain or substituent. So, when it is considered as a side chain, then its name should be written as hydroxy. Okay, so numbering should be given like this: 1, 2, 3. So, therefore, 3 hydroxy, okay, 3 hydroxy cyclopentane carboxylic acid. Okay, this is the IUPAC name of this compound. Now, we will take one more example. CH2 double bond CH, C, Cl, COOH. Okay, and in this the parent chain is, this is the parent chain. Okay, now numbering should be given from this carbon. I say that COOH is a chain terminating functional group, and you should start giving number from that carbon. So, 1, 2, 3, 4. And here, whenever you are writing the IUPAC name of an organic compound, first of all you have to write the prefix, then you have to write the root word, then you have to write the primary suffix and a secondary suffix. So, here the prefix is, side chain is chloro, 2-chloro. Okay, 2-chloro. How many carbons are there? 4. So, but. Okay, and double bond is present at third carbon, 3-ene. And here you no need to mention, whenever carboxyOH is considered as a chain terminating function group, no need to indicate its position. So, therefore, 2-chloro but 3-enoic acid. 3-enoic acid. Okay. Now, we will take one more. CH3, C double bond O, CH, CH3, and this is COOH. Okay. Now, in this we are having two function group. One is ketone and another is carboxylic acid. You know that among ketone and carboxylic acid should be considered as a principal functional group. So, this ketone is considered as a side chain or a prefix. Numbering is 1, 2, 3, 4. Okay. Now, so here its name is 2-methyl and 3-oxo. Okay. The secondary, the prefix of keto is oxo, or else you can say keto. 3-oxo. Total 4 carbons are there. So, therefore, butanoic acid. Okay. This is IUPAC name of this compound. Now, similarly, now we are discussing about aliphatic carboxylic acids, and these are the few examples of aliphatic carboxylic acids and which contain only one COOH group. So, now when come to the classification of aliphatic carboxylic acids, based on the number of COOH groups present in that carboxylic acid, the aliphatic carboxylic acids are classified into several types. They are, first one is mono carboxylic acids. Okay, basing on the number of COH groups, how many COH groups are present in that compound, basing on that number, the carboxylic acids are classified into several types. So, in that, very important, monocarboxylic acids, and the second one is dicarboxylic acids. Okay, and third one is tricarboxylic acids, and the fourth is polycarboxylic acids. Okay. Now, when come to the monocarboxylic acids, the carboxylic acids which contain only one COOH group are called as monocarboxylic acids. So, just now we have taken many examples for the monocarboxylic acids. Okay. Dicarboxylic acids. Dicarboxylic acids are nothing but the carboxylic acids which contain two COOH groups. Okay. Now, we will take a few examples for dicarboxylic acids. So, you can remember dicarboxylic acids by remembering this: oh my such good apples, oh my such good apples. Okay, here the first letter is O. O is nothing but oxalic acid, and this is the dicarboxylic acid which contain 2 carbon atoms. So COH, COH. Okay, it contains how many carbon atoms? 2 carbon atoms. Okay, so and 2 COH groups. Its common name is oxalic acid, and IUPAC name is ethane dioic acid. Ethane dioic acid is the IUPAC name of oxalic acid. Okay, and M is nothing but malonic acid. It is a dicarboxylic acid which contains 3 carbon atoms. Okay, now COOH, CH2, COOH. And here how many carbons are there in this dicarboxylic acid? 3 carbons are there. So its IUPAC name is propane 1,3 dioic acid. Propane 1,3 dioic acid is the IUPAC name of malonic acid. And the next one is succinic acid. Succinic acid is the common name of dicarboxylic acid which contain 4 carbon atoms. So here I am writing COOH, CH2 taken twice, COH. Okay, and its IUPAC name is, here how many carbons are there? 4 carbons are there. So therefore butane, okay, 1,4 dioic acid. Butane 1,4 dioic acid, and G is nothing but glutaric acid, and this is the dicarboxylic acid which contain 5 carbon atoms. Okay, now so its formula is COOH. I am writing CH2 taken thrice, COOH. Okay, now glutaric acid, and it is a dicarboxylic acid which contain 5 carbon atoms, and its IUPAC name is pentane. Here 1,5 dioic acid is the IUPAC name. And the last one is A. A is nothing but adipic acid. Adipic acid is the common name of dicarboxylic acid which contain 6 carbon atoms. Okay, now so its formula is COOH, CH2 taken 4, COOH. Total 6 carbons are there. So the IUPAC name of this compound is hexane 1,6 dioic acid. Hexane 1,6 dioic acid. These are the examples of dicarboxylic acids, or the carboxylic acids which contain 2 COOH groups. Now we will go for tricarboxylic acid. When come to tricarboxylic acid, tri means 3. The carboxylic acids which contain 3 COH groups, are called as what? Tricarboxylic acids. The best example of tricarboxylic acid is citric acid. Citric acid is the example of tricarboxylic acid, and its formula is, okay, this is the formula of citric acid, and how many COH groups are there in this compound? 3 are there. That is why it is called as tricarboxylic acid, and common name is citric acid, and it is obtained from citrus fruits. Okay, now we will take one more example. CH2, CH2. Here I am writing COOH. And competitive examination point of view, this is very important. There is a possibility of asking the IUPAC name of this compound. Most of the students will get confusion while writing the IUPAC name of this compound. You know that whenever if organic compound contain more than one COH group, okay, when there is no possibility of including all the carbons of COH in the parent chain, in this case the terminal E of ANE will be retained. So for example, say here this will be the parent chain, and what is the name of this CH2, CH and CH3, the chain which contain 3 carbons? Propane. So therefore propane, and numbering 1, 2, 3. Okay, propane 1, 2, 3 tricarboxylic acids. So in this case, we have not included this C carbon in the parent chain. That is why I have written carboxylic acid. 1, 2, 3 tricarboxylic acid. But whereas in this in case of dicarboxylic acids, I have included the carbons in the parent chain. That is why I didn't write carboxylic acid. I have written here it is IUPAC name propane 1, 2, 3 tricarboxylic acid. This about the classification of aliphatic carboxylic acid into mono, di, tricarboxylic acids. Okay. Aromatic carboxylic acid. Now we will take a few examples for this aromatic carboxylic acids, and okay, we will discuss their common names and as well as IUPAC names. First, start with this compound. Okay, the IUPAC name of this compound is benzoic acid. This is the common name and as well as accepted IUPAC name of this compound, benzoic acid, or else you can say benzene carboxylic acids. Benzene carboxylic acid. Now, COOH and it is OH. The IUPAC name of this compound is here, it is 1 and 2. So, 2-hydroxy benzoic acid. 2-hydroxy benzoic acid, and common name is ortho-salicylic acid. Its common name is ortho-salicylic acid. Okay. Now, and if I write CH3 here, then you know that if you won't write this COH, then it will be toluene. Okay. Now, the common name of this compound is toluic acid. Toluic acid, and IUPAC name is 2-methyl benzoic acid. Okay. So, when come to this aromatic carboxylic acids also classified into monocarboxylic acids, dicarboxylic acids, tricarboxylic acids. So, whatever I have written here, these are the examples of monocarboxylic aromatic or monocarboxylic aromatic compounds. Okay. Now, we will go for dicarboxylic aromatic compounds. In that, very important are phthalic acids. COOH. This is called as what? Phthalic acid. Okay, phthalic acid. Now, the next one is COOH. Then this is called as isophthalic acid. And the next one is very important, that is COOH. This is called what? Terephthallic acid. Okay, these are the examples of dicarboxylic aromatic compounds. Now we will go for structure and nature of carboxylic carbon. Structure, nature of carboxylic carbon. So here C double bond OH. This is called as carboxylic carbon, and this carboxylic carbon undergo sp2 hybridization, and the shape of this carbon, okay, arrangement is a trigonal planar, and bond angle is 120 degrees. This carboxylic carbon is bonded by 1, 2, 3 sigma bonds and 1 pi bond. Okay, it is surrounded or bonded by 3 sigma and 1 pi bond, and the type of overlapping involved in the formation of sigma bond between carbon and oxygen, this carbon and oxygen, is sigma sp2p. Okay, sigma sp2p is the type of overlapping which is involved in the formation of sigma bond between carbon and this oxygen. Okay. Now the next we will go for its nature. When come to the nature of this carboxylic carbon, you know that among carbon and oxygen, oxygen is more electronegative. Because of more electronegativity, it will have a greater tendency of attracting pi electrons and getting a negative charge, partial negative charge. Okay. So, here this we can write C double bond O, OH. And when these pi electrons are taken by the oxygen, it gets negative charge and it gets positive charge. It means this carboxylic carbon, okay, is getting a positive charge. So, act as electrophile. It acts as a electrophile. It means this carboxylic carbon will have a tendency of attracting the nucleophile. Nucleophile is nothing but a electron rich species. Okay. So, whenever carboxylic carbon is involved in the chemical reactions, and it will try to get a nucleophile because it is having a positive charge, it becomes electron deficient. So, act as electrophile. Okay. Now, but when if you compare with a carbonyl carbon, this is carbonyl carbon. Okay. Carbonyl carbon. In carbonyl carbon also, okay, when oxygen takes up this pi electrons, it gets partial negative charge and gets positive charge, right? Okay, when it gets positive charge, and here in this case also it acts as electrophile. Okay, carboxylic carbon and carbonyl carbon both are having positive charge and both can act as what? Electrophiles. But when come to the electrophilicity, it means in these two the electrophilic character, electron attracting tendency will be lesser. We will discuss that, okay, which is having a less electron density and okay, which act as a good electrophile. Okay, in this case, you know, this is attached with the oxygen having lone pair of electrons. So, therefore, the electrophilicity, the electron density, okay, will be increased by this adjacent oxygen. So, the electrophilic, it is less electrophilic. Therefore, carboxylic carbon is less electrophilic than a carbonyl carbon. Okay. Now, we will go for preparation and properties of carboxylic acid. First, we will discuss preparations, then we will go for properties. Okay. Preparation of carboxylic acids, aliphatic carboxylic acids. Preparation of aliphatic carboxylic acids. Preparation of aliphatic carboxylic acid. You know, aliphatic carboxylic acids can be prepared from various compounds. First, we will go for preparation of carboxylic acids from alcohols. The first one is from alcohols. From alcohols by oxidation. By oxidation. Okay, alcohols, primary alcohols are CH2OH. No, this is called as primary alcohol. Primary alcohols on oxidation in the presence of strong oxidizing agents. You know, what are the strong oxidizing agents? K2Cr2O7H plus, KMnO4H plus. These substances are used as a strong oxidizing agent. So, primary alcohols on oxidation in the presence of strong oxidizing agent, this alcohol will be oxidized to aldehydes. Aldehydes. And these aldehydes on further oxidation, these aldehydes are now further oxidation, you will get a carboxylic acid having same number of carbons as in a primary alcohol. Okay. So, therefore, primary alcohols on oxidation in the presence of strong oxidizing agent will get a carboxylic acids. We will take one example for this so that you can understand this well. Say I have taken CH3CH2OH. This is known as ethyl alcohol or ethanol. This ethanol on oxidation in the presence of these oxidizing agent, strong oxidizing agent, first you will get CH3CHO known as acetaldehyde. This acetaldehyde on further oxidation, you will get acetic acid or ethanoic acid. Similarly, we will take in the examination, they will ask like this. It will be given like this. And this on oxidation, what is the product? What is the oxidation product of this compound? Okay, the product will be here, this will be converted CH2OH, this on oxidation. Okay, first it will be converted into aldehyde, and this on further oxidation in the presence of strong oxidizing agent, you will get this compound. And here the name of this compound is cyclohexane carboxylic acid. So cyclohexane carboxylic acid can be prepared by this compound by the oxidation process using strong oxidizing agents. Next is the preparation of carboxylic acids from aldehydes. Second one, from aldehydes. Okay, this is also by oxidation. Okay, you know that aldehydes on oxidation in the presence of strong oxidizing agents or else weak oxidizing agents. Okay, aldehydes are highly reactive than ketones, so they can undergo oxidation with strong oxidizing agent and as well as weak oxidizing agents. So just now we have discussed the examples of strong oxidizing agents, and when come to the examples of weak oxidizing agents used in this process are Tollens reagent, Fehling's reagent, Benedict reagent and Schipp's reagent, okay, are used as a weak oxidizing agent in the conversion of aldehydes into carboxylic acid. So here aldehydes on oxidation in the presence of strong oxidizing agent or weak oxidizing agent, you will get a carboxylic acid having same number of carbons as there in a aldehyde. Now we will take a simple example, CH3CHO, just now we have taken acetaldehyde on oxidation, you will get acetic acid. Okay, or else if you take this compound, okay, this on oxidation in the presence of strong oxidizing agent or weak oxidizing agent, in this case the CHO group will be converted into COOH. So in this oxidation, very simple, CHO group is converted into COOH. Aldehyde group, function group is converted into carboxylic acid group. Okay, and the next is third one, that is the preparation of carboxylic acid from nitriles, cyanides. Third one is from nitriles. You know, nitriles are called as cyanides. Nitriles, amides. Okay. Next one is the preparation of carboxylic acids from nitriles, amides. Nitriles are also known as cyanides. Okay. Now this is by hydrolysis. You know that hydrolysis is nothing but reaction with water in the presence of acid or base. Cyanides on hydrolysis are CN. On hydrolysis in the presence of acid or base, OH minus. First they produce R C double bond O NH2. Okay, these are nitriles, nitrile, and these are amide. Okay, cyanides on hydrolysis in the presence of H plus or OH minus. First you will get amides. These amides on further hydrolysis in the presence of acid or base, you will get R, COOH and ammonia as a byproduct. So therefore carboxylic acids can also be prepared by the hydrolysis of cyanides, or you can say nitriles. We will take one example, CH3CN, methyl cyanide. Methyl cyanide on hydrolysis in the presence of acid H plus, you will get first you will get CH3 C double bond O NH2. This is known as acetamide. Okay, acetamide is the common name of that compound, and IUPAC name is, two carbons are there, ethanamide. Ethanamide is the common name of, okay, ethanamide is the IUPAC name and acetamide is the common name. This acetamide on hydrolysis in the presence of acid, here you will get CH3COOH, acetic acid plus NH3. Next from amides. You know, amides are C double bond O NH2. These are called as amide. Amides on hydrolysis, okay, in the presence of acid or base, here you will get R C double bond O OH plus NH3. Okay, now I am taking acetamide CH3 C double bond O NH2. This on hydrolysis in the presence of acid, here you will get CH3 C double bond O OH plus NH3. Or else we can take this type of compounds also, C double bond O NH2. This on hydrolysis in the presence of acid. Very simple. In these reactions, you have to convert C double bond O NH2 as C double bond O OH. That's all. Okay. Now, so therefore here what I said, C double bond O NH2 group should be converted into C double bond O OH. In place of NH2, you have to write OH. Clear? Now, we'll next this about the preparation of carboxylic acids from nitriles, amides, and the fourth one is from Grignard reagent and carbon dioxide. This is nothing but dry ice. You know that solid CO2 is called as what? Dry ice. Okay, from Grignard reagent and carbon dioxide, this is called as carboxylation. This process is known as carboxylation. Okay. Now, you know that Grignard reagent is nothing but RMGX. Alkyl magnesium halide is called as Grignard reagent, and here X may be chlorine, bromine, iodine, and R can be anything. It may be alkyl group or aryl group. Okay, you can take R is not CH3 or C2H5 or C3H7, like that we can take. Okay, and you know that Grignard reagent can be prepared from alkyl halides in the presence of dry ether. You know, alkyl halides on reaction with magnesium in the presence of ether, dry ether. Here you will get RMGX. For example, say I have taken CH3Cl, methyl chloride I have taken. Methyl chloride on reaction with magnesium in the presence of dry ether, you will get CH3MgCl. And what is the name of this compound? Here you see, this is methyl magnesium chloride. Methyl magnesium chloride is the name of this compound. Okay. Now we'll discuss the preparation of how carboxylic acids are prepared from Grignard reagent and carbon dioxide. So Grignard reagent is nothing but RMGX. Just now I said, when react with carbon dioxide, okay, carbon dioxide we can write C double bond O double bond O. And you also know that in Grignard reagent, alkyl group carries negative charge and magnesium will carry positive charge. So therefore, whenever electrons are shifted like this, oxygen gets negative charge and carbon gets a positive charge. So therefore, being a negatively charged species, it will attack on the carbon because carbon is having a positive charge. Okay. Now, so therefore, here you will get C double bond O MgCl, and this is R. And this on further hydrolysis, you will get R C double bond O OH plus MgOH Okay. So therefore, in the preparation of carboxylic acids using Grignard reagent and carbon dioxide, in the carboxylic acid group, okay, this part will come from carbon dioxide and this part will come from what? RMGX. Now we'll take one more example for this. Say if you want to prepare CH3, C, CH3, CH, CH2, COH. In the preparation of this carboxylic acids, in the examination they will ask you, okay, which Grignard reagent is used for the preparation of this carboxylic acid. Okay, very simple. I said that this part will come from carbon dioxide, and the leftover part, this part will be taken, will come from a Grignard reagent. So therefore, the Grignard reagent used in the preparation of this carboxylic acid is CH3, CH3, CH2, Mg, Br, and it is carbon dioxide. Okay. Now, this is nothing but this is isobutyl magnesium bromide. So, isobutyl magnesium bromide on reaction with carbon dioxide will get this compound, and the name of this compound is 1, 2, 3, 4, 3-methyl, 4 carbons are there. So, therefore, butanoic acid. This is very important, and we will take one more example for this. Okay. Say if you want to prepare this compound, say you want to prepare this compound from Grignard reagent. So, in the preparation of this compound from Grignard reagent, okay, which Grignard reagent should be taken? Okay. The Grignard reagent used in the preparation of this carboxylic acid is benzene, not benzene, cyclohexane, and here you have to write MgCl. So, this is cyclohexyl magnesium chloride. This on reaction with the carbon dioxide, okay, and followed by hydrolysis, you will get a cyclohexane carboxylic acid. It's very simple. Next term, we will go for a fifth one. From acid derivatives, from acid carboxylic acid derivatives. First of all, you should know what are acid derivatives. Acid derivatives are nothing but esters, anhydrides, and acid halides, okay, and amides. Okay, these are called as what? Acid derivatives. So, esters we can represent as R, C double bond O, OR, and anhydrides R, C double bond O, C double bond O, R, and acid halides R, C double bond O, X. Here X may be chlorine or bromine, and amides R, C double bond O, NH2. Okay. Now, so carboxylic acids can also prepared from acid derivatives such as esters, anhydrides, and acid halides and amides. Amides already we have discussed, and here hydrolysis of these acid derivatives, hydrolysis of acid derivatives. First, okay, we take esters. Esters on hydrolysis, okay, in the presence of acid, ester and hydrolysis in the presence of acid, you will get R, C double bond O, OH plus ROH. So, you will get carboxylic acid and alcohols. Okay, we will get a mixture of carboxylic acid and alcohols, and here this is a reversible reaction. Okay, we will take one example, CH3 C double bond O, O C2H5. It is known as ethyl acetate. Ethyl acetate is the common name, and IUPAC name is ethyl ethanoate. This on hydrolysis in the presence of H plus, you will get CH3 C double bond O, OH plus ethyl alcohol. Okay, you will get mixture of ethyl alcohol and acetic acid. Now, from acid halides, R C double bond O. Okay, here I am taking acid chlorides. This is acid chloride. This acid chlorides on hydrolysis in the presence of H plus. Here you will get R C double bond O, OH plus HCl. You get carboxylic acid and HCl. For example, say I have taken acetyl chloride. Its common name is acetyl chloride, and IUPAC name is ethanoyl chloride. Ethanoyl chloride is the IUPAC name, acetyl chloride is the common name. Acetyl chloride on hydrolysis in the presence of acid H plus, you will get CH3 double bond O OH plus HCl. Okay. Now similarly, if you take this type of compound, in this case you will get a COOH plus HCl. Here it is hydrolysis in the presence of H plus. Okay. Now next we will go for hydrolysis of acid chlorides in the presence of a base. Here I have taken H plus. If the hydrolysis of acid chlorides or acid halides is carried out in the presence of a base, you will get we won't get carboxylic acid, we will get carboxylate ion or salt of carboxylic acid. For example, say RC double bond OCl, this on hydrolysis in the presence of say NaOH, a base. Okay, here you will get RC double bond ONA plus, okay, you will get a salt and HCl. Okay, or else you can write like this also, RC double bond O minus. This is known as carboxylate ion. If reaction is carried out in the presence of acid, directly you will get carboxylic acid. But if the hydrolysis of acid chloride is carried out in the presence of a base, you will get a salt of carboxylic acid, or else you can say carboxylate ion. Next we will take anhydrides. So we have just now discussed the preparation of carboxylic acids from esters. Next one is acid chlorides, and next we will go for anhydrides. RC double bond O C double bond O R, acid anhydrides. On hydrolysis in the presence of acid or a base, here you will get you will get 2 moles of, if it is a symmetrical anhydride, then you will get 2 moles of RCOOH. Okay, we will take one example, CH3 C double bond O C double bond O CH3, known as acetic anhydride, and IUPAC name is ethanoic anhydride. This on hydrolysis in the presence of H plus, here you will get 2 moles of CH3 COOH, acetic acid. Okay, so this about the preparation of carboxylic acids from esters, from acid chlorides and anhydrides. Already we have discussed the preparation of carboxylic acids from amides. Next one is preparation of aromatic carboxylic acid. Preparation of aromatic carboxylic acids. Okay, preparation of aromatic carboxylic acid. First one, I said that carboxylic acids can be prepared by the oxidation of alcohols. So here I am taking benzyl alcohol, CH2OH is called as benzyl alcohol. This benzyl alcohol on oxidation in the presence of strong oxidizing agents, here you will get benzoic acid. Okay, benzyl alcohol on oxidation in the presence of strong oxidizing agent, here what you will get? Benzoic acid. Okay, because this is the primary alcohol. Primary alcohols on oxidation in the presence of strong oxidizing agent give carboxylic acids. And the second one is aldehydes. Aldehydes on oxidation in the presence of strong oxidizing agent or weak oxidizing agent, in that case also will get carboxylic acids. So the aromatic aldehyde is benzaldehyde, CHO. This is known as benzaldehyde. Benzaldehyde on oxidation in the presence of strong oxidizing agent, okay, here you will get benzoic acid. And very important is benzaldehyde do not give a failing test, even though it is having a CHO group, aldehyde function group, it do not respond to the failings reagent. This is very important. The aldehyde, okay, the aromatic aldehydes do not give a failing test, but whereas the remaining aldehydes can give failings test. Very important. Okay. Now the third one is I say that carboxylic acids can be prepared from Grignard reagent and carbon dioxide, and that process is known as carboxylation. So here I am taking a Grignard reagent, that is phenyl magnesium chloride. Phenyl magnesium chloride on reaction with carbon dioxide and followed by hydrolysis. Here you will get, on benzene ring you will get COOH, and you know that this process is known as a carboxylation. Okay, and this is nothing but a phenyl magnesium chloride, and CO2 is nothing but dry ice. Solid CO2 is called as dry ice. Phenyl magnesium chloride and dry ice, okay, when they react each other, will get a benzoic acid. And next we'll go for the fourth one. You know that say I have taken cyanides, phenyl cyanide. You know that cyanides on hydrolysis in the presence of acid or base produces carboxylic acids. So phenyl cyanide on hydrolysis in the presence of acid, here you will get COOH. Phenyl cyanide on hydrolysis in the presence of acid will get benzoic acid. Similarly, you can take hydrolysis of benzoyl chloride. This is known as benzoyl chloride. Benzoyl chloride on hydrolysis in the presence of H plus, here you will get a benzoic acid. Okay, benzoic acid, and the byproduct is HCl. Okay, now the next so or else you can take even benzamide also you can take. This on hydrolysis you will get benzoic acid. Okay, or else you can take PH C double bond O C double bond O PH. This on hydrolysis, this is called what? Benzoic anhydride. Benzoic anhydride on hydrolysis in the presence of acid, here also you will get 2 moles of benzoic acid. Next is preparation of aromatic carboxylic acids by the oxidation of alkyl benzene. So the next one is very important, oxidation of alkyl benzene. Okay, now alkyl benzene on oxidation, this is alkyl benzene. Alkyl benzene on oxidation in the presence of KMnO4 H plus, potassium permanganate. So here it will give benzoic acid. Okay, benzoic acid you will get alkyl, and in this case very important is this R may be methyl or ethyl, it may be primary carbon or secondary carbon, or it may be isopropyl, or it may be N-propyl. Okay, it can be either primary carbon, okay, primary, secondary carbon, but it should not be tertiary carbon. So if it is like this, okay, now this do not undergo oxidation and do not lead to the formation of benzoic acid. Okay, here this alkyl group should be methyl or ethyl or isopropyl or propyl. Now we will take toluene. Methyl benzene is called as toluene. Toluene on oxidation in the presence of KMnO4, here what you will get? Very simple, the COOH group will be converted into COOH. And similarly you can take ethyl alcohol C2H5, this on oxidation in the presence of KMnO4. Okay, here you will get COOH. Okay, so therefore alkyl benzene on oxidation in the presence of KMnO4 you will get carboxylic acid. Now say here I have taken CH3 and CH3. Okay, this is called what? Paraxylene. Paraxylene. This paraxylene on oxidation in the presence of KMnO4 KOH. Here you will get COOK. This on further reaction with the acid, you will get COOH, which is known as teriphthalic acid. Okay, so this is very important. In the examination there is a possibility of asking question related to this topic, oxidation of alkyl benzene, and this alkyl carbon should be either primary or secondary, but it should not be a tertiary. And here if you take cumene, isopropyl benzene. So this is called as isopropyl benzene. Isopropyl benzene is known as a cumene, and this on oxidation in the presence of KMnO4, here also you will get carboxylic acid known as benzoic acid. And the last preparation is preparation of salicylic acid. This is very important. Salicylic acid can be prepared by a Kolbe reaction from phenol. Okay, phenol OH. Phenol on react with sodium hydroxide, you will get sodium phenoxide, ONA. This sodium phenoxide on further reaction with CO2 and followed by hydrolysis, okay, you will get salicylic acid. This become OH and this is COOH, known as ortho-salicylic acid, and this reaction is known as a Kolbe's reaction. That's all, my dear students. This is about the preparation of aliphatic and aromatic carboxylic acids.